Hi guys, welcome back to Math with James. So today we're going to talk about the other branch of calculus, integration. Actually, there are two branches of calculus. The first one is called differentiation, which we have been talking about all the time. And the other branch is called integration. These two actually are inverse process of each other. What does that mean? Let me give you an example. Some of the definitions might be really hard and complicated to understand, but this one is going to be super easy. Don't be scared away. If you have a function f(x) and you want to differentiate it, you get the derivative for the function x, which is fx prime. For example, if the function fx is x squared, then the derivative of x squared is 2x, according to the formula, right? What if you want to do the inverse process? Actually go from the derivative backwards to the original function, and that is called integration. And therefore, the integral of 2x is x squared. So we use the stretched s notation. So the integral of 2x with respect to x is equal to x squared. With this being understood, so it would be pretty easy for us to solve this original problem we have for today. All right, so the question says on what interval is the curve y is equal to the integration of t squared divided by t squared plus t plus 2 from 0 to x concave downward. So let's not consider about this complicated right side for the moment being. Let's just think about y for any function. So if you have a function y, when is it concave downwards? Let's take a look at the graph. If the curve of y goes this way, then it is concave downwards, and the test of it is that the second derivative of y is smaller than 0. All right, what if the curve goes this way? Then we say that it is concave upwards. So the second derivative of y is greater than 0. So we're going to use these two testers to solve the original problem for today. The original function y is equal to the integral of t squared divided by t squared plus t plus 2. The relationship between y and this whole thing over here is pretty simple. So this thing in the y box is derivative y, right? And y is the integral of this thing. So the first derivative y is equal to this whole thing, t squared divided by t squared plus t plus 2. Y prime prime is equal to the derivative of the first derivative. The final result is t times t plus 4 divided by t squared plus t plus 2 squared. Then y prime prime should be smaller than 0. And we know that the denominator has to be greater than 0 because it's some number squared. If the denominator is greater than 0 and the value of this whole fraction is smaller than 0, then the numerator has to be smaller than 0. So t times t plus 4 is going to be smaller than 0. T actually is smaller than 0 and greater than -4. So the interval for the function y that is concave downward is going to be from -4 to 0. Problem solved. I'll see you guys next time. Take care.